Dear student, today we are going to start with the topic solution of system of homogeneous linear equation. Consider the system of three equation and three unknown. A1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. In matrix equation notation, these equation can be written as a1 b1 c1 first row, A2, B2, C2 second row, A3, B3, C3 third row. This is the coefficient matrix X, Y, Z. This is the column matrix of the unknowns, and D1, D2, D3 is the column matrix of the constant. Homogeneous linear equation. If all the constant D1, D2, D3 are 0, then B equal to 0. Then the matrix equation AX equal to B reduces to AX equal to 0. Such a system of equation is called the system of homogeneous linear equation. Homogeneous linear equation is always consistent, solution always exists. There now the two cases arises whether the solution is a trivial solution or a unique solution or infinite number of no trivial solution exists. For this, we first of all we find the rank of the matrix A. If the rank of the matrix is equal to the number of unknowns, then the system of equation is said to have a unique solution or trivial solution. And when the number of rank is equal to the number of unknown is less than the number of unknowns, then the infinite number of known trivial solution exists. Suppose we consider an example. We have to solve the system of equation 3x minus y plus z equal to 0, minus 5x plus 6y minus 5z equal to 0, 5x minus 2y plus 2z equal to 0. In matrix notation, since you can see that these three equations are homogeneous equation because it is in the form x equal to 0. The value of here ax equal to 0. The value of b is 0. So we can write like this, a 3 minus 1, 1, minus 15, 6, minus 5 in second row, 5 minus 2, 2 in the third row. The value of b is 0. So only we have this coefficient matrix A. Now, in order to solve this system of equation, first of all, we will try to reduce this matrix A by reducing it into echelon form. Echelon form, with the help of echelon form, we will find the rank of A. And if the rank of A comes out to be equal to the number of factors, then the system of equation will have the trivial solution. And if the rank comes out to be less in number of unknowns x, y, z, then the system of equation will have infinite number of solution. In that case, we have to take one constant as k, where k is an arbitrary constant. Now we are trying to reduce this equation to echelon form. So first we have applied the operation R215 means R2 tends to R2 minus 5 times of R1 and R3 tends to R3 minus 2 times of R1. So in this we get in first row we get 3 minus 1 1. In second row we get 0 1 0 and in third row we get minus 1 0 0. So our matrix reduces to this. Now we have applied the operation R3 tends to R3 minus 1 means we have multiplied this row 3 by minus 1. So our matrix row 3 changes to 1 0 0. Then first, because in echelon form we have to make the pivot element to one element as 1 if it is not so that we can easily reduce our matrix into echelon form. So we are doing that only. So we have interchanged rows 1 and 3. CR1 3, 1 is interchanged by 3. So we get in first row 1 0 0, second row 0 1 0, third row 3 minus 1 1. Okay, now we have, with the help of this element 1, we have to make these two elements 0, R21 and R31 0. So this is already 0, we will make it 0. So we'll apply the operation R3 tends to R3 minus 3 times of R1. With the help of 1, we have to make this element R31 as 0. So we have done this, R31 multiply by minus 3. So means R3 tends to R3 minus 3 times of R1. So we get this in first row as it is, second row as it is, and third row we get by applying this operation 0 minus 1 1. Okay, now now we'll try to reduce more. As we can see, the now you will make this element as it is, a21 as a22 as it is. With the help of this second row, we'll make this these elements 0, because the number of non-zero rows is equal to the rank of the matrix. So we have applied the operation R3 tends to R3 plus R2. You will add these two rows, and in this case we will get this 0. Third row becomes 0, 0, 1. Now, if we try to reduce it more, we cannot reduce this matrix further. It means the rank of matrix, this A coefficient matrix, is equal to the number of unknowns, and number of unknowns you can see there are three numbers of unknown x, y and z. So the rank of A is equal to the number of unknowns. It means the system will have a trivial solution. The system is consistent and have a trivial solution, and the value of x, y, z is. So you can see this is again a homogeneous system of equations, because the value of this b is 0. So first of all we have put in and the homogeneous equation are always consistent. We'll put in this form x equal to 0, 4 parameters, 3 rows. This is a 2, 3, minus 1, minus 1, 4, minus 6, minus 2, 2, minus 6, 12, 3, minus 4. Okay, now we'll try to reduce it into echelon form, and we'll try to find the rank of this matrix, because if the rank of this matrix is less than number of unknowns, then we can easily see that the system of equation will have a non-trivial solution or infinite number of solution. And if when the rank of the system is equal to the number of unknowns, then the system will have a trivial solution. So now we are trying to reduce it by echelon form. See, we have applied the operation R2 tends to R2 minus 2R1, R3 tends to R3 minus 3R1. So with the help of this element, we have reduced this matter. We'll try to reduce it 1 if possible. We'll try to reduce A to 1 as 1. So with the help of this element, we have done this. Again, we have reduced. Now we are trying to reduce this matrix. You can easily see this. We have divided row 2 by 4 minus 4 and row 3 by 7. Yes, we see that row 2 and row 3 are identical. By adding the subtracting them, we will get the one complete row 0. Yes, this is now the echelon form, and we can easily see that the rank of the matrix is equal to 2, because it equal to number of non-zero rows. Yes, so the rank of A is equal to 2, and number of unknowns are 4. So it means rank is less than number of unknowns. It means the system is consistent but have infinite number of solutions. Now how many parameter we have to assume for this? We have to subtract number of unknowns minus rank. Will give number of unknowns are 4, and we get the rank 2. So this is equal to 2. So it means we have to assume two arbitrary constant. Now the reduced form of equation, this is this. Again ax equal to 0. We'll multiply this. We get the rank 2w plus 3x minus y minus z equal to 0. 3x minus z equal to 0. Now we'll assume two constant here. Let any variable you can suppose. We have assumed here y equal to k1, z equal to k2. Then we get x is equal to 1 by 3 k2 and w is equal to 1 by 2 k1. In this way, we have calculated the value of all the substituting these values. And since the system of equation has an infinite number of solution, because the number of rank is equal to the rank of augmented matrix is equal to the rank of A, but it is less than number of unknowns. So we have to give the infinite number of solution. For this, we have to assume any one arbitrary constant as k. In that way, in form, we have to calculate other values. So the values comes out to be x equal to k minus 1, y equal to k minus 1, and z equal to k, where k is any arbitrary constant. Thank you.